Let's talk about systems and system environment. So, a system is defined as groups of objects that are joined together in some regular interaction toward the accomplishment of some purpose. Um, Example of a system could be an automobile factory, and then there are further subsystems, or you would say departments in an automobile factory. Then we can say that a system is often affected by changes occurring outside the system, and that outside portion is called environment. And system environment are basically various factors which are or capable of affecting my system. So let's say taking example a factory, right? So arrival orders, effect of supply on demand, relation between factory output and arrival. So let's say if I'm manufacturing products, right? But then my productivity is dependent on my raw material and the arrival rate. So if there is a delay in raw material supply, then it will definitely affect my production. Giving you example of banks, right? Arrival of customers. It's also like a very key attribute. So arrival of customers could be my system environment, like at what rate customers are entering in my bank, and what's the queue length, stuff like this. So that's basically my system environment. And then this environment, such as I said, arrival of customer, this is basically affecting my system, and my system is bank. So this means that the arrival of customer is kind of affecting the bank system, right? So let's say if you have more and more customers entering your bank, you will have more and more people waiting in the queue. As we already talked about system and environment, so let's talk about components of system. Entity is basically an object of interest in a system. Example could be machines in factory, departments, order, parts, or also you can say products are the entities. Let's talk about attribute. So attribute is basically the property of an entity, such as speed, capacity, quantities of each order, type of part, or number of machines in a department are attributes of a factory system. Activity, a time period of a specified length, or you can say any process causing changes in a system is called an activity, such as like any manufacturing process of the department, welding, stamping. A state of the system, a collection of variables that describe the system in any time. So status of machine would be busy, idle, down. Or you can say that the state of a system is defined as the collection of variables that are necessary to describe a system at any time, relative to the objective of the system, or um, you can say state of the system mean a description of all entities, attributes and activities as they exist at one point in a time. The status of machine, as we said, could be busy, idle, down. Because we are dealing with the system, so we need to have some event. Event is instantaneous occurrence that may change the state of the system, um, such as a breakdown of a machine, or machine failure, or arrival of a customer, or you can say, okay, arrival of your raw material, something like this. So here we can call them as events. mm, let's talk about the endogenous system. So the term endogenous is used to describe activities and events occurring within a system. Activities and events occurring within the system. So for example, drawing cash in a bank, right? So that's basically within your system. Exogenous system, in which activities and event occurring with the environment, um, so such as arrival of customers. Let's consider a banking system, right? So our system would be a bank. um, our customers will be our entities. Attributes would be account balance. um, Activities would be making deposits, and events would be arrival of customers or departure of customers, and state variables would be number of customers waiting. So that is basically our system and components of system. Let's talk about discrete and continuous systems. So a discrete system is one in which state variables change only at a discrete set of points in time. For example, bank. So we can say that the number of customers changes only when a customer arrives at that particular bank, or when the customer uh, is satisfied, or his her task is done, or service is provided to that customer, and that customer is leaving. So the system is changing at discrete points. Other than that, the system is not changing at all. It's not like continuous. Second one would be a continuous system. So a continuous system is one in which state variables change continuously over time. So such as head of water. So from head of water mean height. When height is represented in terms of meters and energy, right? It's called head. So head of water behind the dam, and you cannot like discretely measure it, because this head of water is changing continuously. So it's a continuous event, and the system under consideration is a continuous system. So let's talk about types of so the various types of model are mathematical or physical model, static model, dynamic model, deterministic model, stochastic model, and deterministic model. So let's discuss those models. So in mathematical model we uses symbolic notation, and um, basically we are using mathematical equations to represent a system, while in static model uh, we represent a system at a particular point of time, and this is also known as Monte Carlo simulation or computer simulation. In dynamic model represents system as they change over time. So if we are doing or performing simulation of a bank over time, right, then we can call this as dynamic modeling. Deterministic model. So deterministic model contains no random variable. They have a known set of inputs which will result in a unique set of outputs. So, such as the arrival of patients to the dentist at the scheduled appointment time. So, there is no uncertainty involved also, because we are not talking about any random variables. So in deterministic model, you know that okay, at that particular time, um, what kind of activity is going to happen, right? Because there is no randomness in the system. There are no random variables involved. However, in stochastic model, we have random variables involved, and um, random variables act as an inputs to our system in stochastic model. So random inputs will lead to random outputs, such as simulation of a bank involving random inter-arrival of customers, and then random service times for customer, because you know service time is not constant for every customer. So that's why it's a very good idea to draw samples for inter-arrival time and service time from a probability distribution. And in stochastic model, like the banking example, you have no idea that who or which particular customer will enter my bank at what time. It's completely random. So here is your simulation models, and let's talk about discrete event simulation model. Um, so discrete event simulation model, significant changes occur at discrete time in instances, or you can say modeling. Discrete event system simulation is concerned with modeling of systems in which state variable changes only and only at a discrete set of points in system. So that's very important to remember. um, let's talk about steps involved in simulation study. So it's like a very easy flow diagram. So first of all, let me zoom it in for you people. So first of all, you need to do this problem formulation part. So you need to know about what my problem is, my what is my problem statement, and this when you are defining the proper problem statement. So you define that proper problem statement with by providing good details. That's basically the key here. Next is setting of objectives. So you clearly define your objectives, and overall project plan. And in this project plan, you clearly define that what my simulation model will be doing. In addition, what kind of questions my simulation model will be answering at the end. So that's basically your second portion. And in this section you need to know that, okay, how many um, workers do I need or helpers do I need for this simulation model, and how many simulating hours do I need in order to run that simulation. Next step is to collect the required data. And when we're talking about data collection, it's the historical data, because we will be making inference or making decisions on the basis of that decision data. Again, before that, um, we need to cover the model conceptualization, which mean abstract features. So when I'm talking about abstracting features, so you need to identify that which features are the most important or essential, and I want those features in my system, because you cannot have all the features in your model, right? And once you identify those essential features, you try your very best to incorporate that in your simulation model, and then you are basically collecting related data to that. um, a very good idea would be to start the simulation model with relatively simpler model, and then you add on different features. In addition, what you want to do, you want to involve the decision makers and stakeholders in your simulation model. So here are a few tips for you people. So next step would be to translate model, right? Step 5. So what you are doing, you basically set up a computer program in which you are providing some inputs to that computer program, and that computer program in return is providing some output to you. uh, so one after computer program setup, you can't stop here. You need to verify that computer program, that it's kind of like an internal check, where in uh, verification you want to check that whether my software is doing what it is supposed to do or not. So that's basically like internal, and if it is doing everything correctly, so then you go to the next step, which is the model validation. And usually model validation is done outside. uh, so verification is inside checking of your programming computer program, that whether it is doing what it is supposed to do or not. And once you get results, you would like to validate your results with real life systems, that whether my results are making sense or not, or am I getting funky or bad results. So once you are initially happy with the validated result, next step would be to do the experimental design. In experimental design, you would like to know that, okay, what would be my simulation speed, what would be my input parameters, and how many replications do I need for each scenario. stuff like this. That is what we are defining in experimental design portion. uh, in production runs and analysis, basically you are checking the performance of your analysis, that whether the runs are they enough or not. If you are satisfied with that, good enough. If not, then you go for more runs. For more runs, I mean more replications, right? More iterations. And if you are happy with this, then you can move to the next step. So if you are happy with your number of runs, right, and you're saying, okay, I don't need any more runs, so then you basically move to the documentation and reporting steps. And if you are happy with that, then you are basically going to implement whatever the results were recommended by your simulation model. So the step number 11, which is documentation and reporting, it's extremely important, because you are basically documenting every step which was deployed in simulation model. It's very much possible that you are working on a simulation project, and your team members are being or requested to work on another project. So if you have a new team member, or maybe you are required to work on another project, so the new person working on this simulation model can understand that they followed which particular steps, what features they are including, what are their parameters. On top of that, what were their assumptions when they were making their simulation model. So that is why documentation and reporting is extremely important step in simulation. On top of that, in documentation and reporting, you also add that how much efforts were involved in data collection process, and how much data was basically collected. So extremely important step is 11, step number 11. So this is your lecture, and in case if you have any questions, please you can email me. Okay, students, take care and